Okay, so I've been musing a lot over multiplication in the last couple of days. I made a video called In Defense of 1 times 1 equals 2, which is that notion that Terrence Howard is trying to push right now. And more than a defense of that actual calculation, which is inherently untrue, it was a defense of what I believe is the disposition of making an argument like that. And basically no one saw it here on YouTube, but on TikTok it caught me some flack from a wide variety of people, many of whom are of the variety that Eric Weinstein referred to as midwits, which I thought was hilarious. A great number more were from a variety that are not, interested in hearing ideas and contending with them, but rather arguing with what their straw image of what you're saying is. So they just talk to themselves in the comments. Got a lot of those. The point is, I talked about multiplication and multidimensionality and the inherent change in units that occurs when you multiply. So, we're familiar with 1 centimeter times 1 centimeter equaling 1 square centimeter. But we don't tend to look at things in the same way when we're talking abstractly. So when we say, when we're counting, which we can all agree that addition and multiplication accomplish identical things through varied operations. But when you're counting something, you have 1 of, 2 of, 3 of, whatever. There's another way in which you can look at that, which is to say that you are multiplying a value measured in instantiation, in instances. You're multiplying that by a value of existing things. So to say 1 of something is to say 1 instance times 1 thing. So this is all a bit unnecessary, really, but it is nonetheless true to say that counting 1 marker is to multiply marker by instance, and each dimension given a value of 1, and you therefore have a square unit. By counting this thing, you end up with a square unit called 1 marker instance. And so multiplication can be viewed in any situation as taking you into 2 dimensions. That was the entire basis of the last video I made. But making that video and talking with people in the comments, it got me thinking about multiplication in general, and I just began to wax philosophical about it, and I really liked where this thread went in my mind, so I thought I'd share it out loud with you guys and just hear what your thoughts are on it. So this is where I went. Got my handy little slate here, chisel, and I'm going to go with green. I like green better. So my thoughts went as follows. When we're dealing with abstract numbers, like when we say the number 10, and we're just dealing with it mathematically, unattached to units, or in other words, abstract, right? We just say 10, right? Now, when we get a little more into the weeds, the most common way that we choose to envision the number 10 is in a number line in 1 dimension. So we give this line a value of 10 usually by breaking it up into equal parts. I'm not going to, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 segments, right? Segments, not points on the line. We break it into 10 equal parts, and we can decide to just think of this as instantiation, 1, 2, 3, 4, 5, or we can associate units with it. We can say 10 centimeters, right? A one-dimensional construct broken into 10 distinct pieces with a value of 1. Multiplicity is our easiest way of understanding the scale of things. We decide what the minimal value is, in this case 1, and we say that this value is equal to 10 of those. Now, inherently, this value is just its own thing, and it can be represented by this line without any segmentation. But we call it 10, and we tend to envision it like this. Another way to look at segmenting this line into 10 pieces, another way to think about that is to put the same thing into 2 dimensions. So here you have 2 axes, and we can imagine that this axis represents length. And we can imagine that this axis represents instantiation. So what we're saying is that in the dimension of length, a value of this multiplied by a dimension of instantiation with a value that is this, we call it 10, but it is just what it is without segmentation. Its size is its value in this representation. So a value of this in the dimension of length times a value of this in the dimension of instantiation gives us an area with a value that, again, we refer to as 10, but this time it is in length instantiation. That's the unit now. We can further refine our definition and say that it is, if these are centimeters, we can say that this area with a value of 10 represents 10 centimeter instances, taking into account both of our units, multiplying them together, thus creating a new unit. So this, and this, and this, and just the written number 10, these are all the same thing. These are all constructs that we use to envision the same thing. And this thing is a value of 10. Now this caused me to think about something much more interesting, so follow me here. So I'll tell you why envisioning it in 2 dimensions is favorable over envisioning it in 1 dimension. This thing that we tend to think of like this, a value of 10 along a single dimension, is better understood as an area. And the reason I say it's better understood is because in our previous example, we had a 1 by 10 that gave us our value of 10 in 2 dimensions. And it told us something about it. It told us that value is 10 instances of 1. We can invert the axes and say it was 1 instance of 10, but you can also, in 2 dimensions, envision it as a value in the dimension of length of 2, multiplied by a value in the dimension of instantiation of 5, right? So you can think of it as 2 instances of 5, 5 instances of 2, 1 instance of 10, 10 instances of 1, 4 instances of 2.5, 2.5 instances of 4. You can morph the area as long as it maintains the same value of 10 in 2-dimensional space. You can morph the area around to understand it in different ways by analyzing its constituent parts in these 2 different dimensions. Or in other words, taking this abstraction that we're dealing with and bringing it up into greater dimensionality gives us additional perspectives on what it is. It gives us a fuller understanding of what it is by giving us more ways to look at it, to understand it. So the thought train from here went really just off the rails into philosophy, but it kept me endlessly entertained yesterday. And the idea is this, that virtually anything, any abstraction or any model or construct that we deal with to help us understand the world, including the fact that everything that we deal with in 4-dimensional space-time is pretty much universally agreed upon to be a projection into 3 spatial dimensions and 1 dimension of time. A projection of something whose base nature we don't fully understand. We can't fully interface with, but whose projection into these 3 spatial dimensions and 1 temporal dimension that we perceive and that we're capable of interacting with, its projection is something we can understand. We can interact with the thing by understanding a model of it. Much in the same way that we, create models of things like the number 10, the value 10. And the more complex our model, or the greater number of dimensions it includes, the more we can understand it, the better we can understand it. So my thinking is that whether base reality includes 14 dimensions, like has been posited by Eric Weinstein, or whether it includes some other finite or infinite number of dimensions, there is inherently complex multidimensionality that can be associated with anything. And while our models work perfectly fine for understanding those things in a way that we can deal with them in the day-to-day, a better understanding of those things involves zooming out into greater dimensionality, incorporating more of the available dimensions of information of what that thing is. Now, where it really gets off the rails is we can obviously understand 10 in terms of 2, right? We can reckon it in terms of 2 by saying that it is 5 of those. There are 5 instances of a value of 2 length in length 10, right? But if you take a 3-dimensional object like this marker, whose greater dimensionality is unknown to me, but which must have a greater dimensionality, could I, in theory, zoom out far enough into its many dimensions to understand a marker in terms of sorrow or some other abstraction, right? I can't do that, but could it theoretically be done by an intelligence greater than a human intelligence? Something that can better interface with the higher dimensionality that base reality must include. I can understand this marker in terms of atoms, right? I can divide it by its constituent atoms and say that in the dimension of instantiation, it includes however many quintillion whatever great number of atoms, right? It's easy to divide things into physical packets that we understand and lay that dimension normal to our dimension of instantiation. That's easy. But what's not available to us is to reckon an object in terms of units that its 3-dimensional projection does not include, like in the example of trying to divide it by sorrow. I could never understand this thing in those terms. I could never reckon it in those terms. But could I, if I understood base reality? If I knew everything, if I could see the finite or infinite multidimensionality of anything, could I then understand it in terms of anything else, abstract or otherwise? My thinking is yes, but this is all pretty uselessly hypothetical and really just a thought exercise and maybe more philosophical than anything else. But point is, it kept me entertained, and it came off of the heels of talking about 1 times 1 equals 2, which, again, I'll state for the record, 1 times 1 does not equal 2 in any system of accounting that you could reasonably justify. And Terrence Howard can take issue with 1 times 1 equaling 1 if he wants, but he can't say that it's wrong in the system that we have developed, which is a self-consistent system that works and describes things in real life. He could, if he wanted, suggest an alternate self-consistent system of accounting for things that does not include the solution of 1 times 1 being 1, but that's not what he's doing by saying 1 times 1 equals 2. And his quote-unquote proof of 1 times 1 equaling 2, which sits in the first couple of pages of his book on his website, it starts on a flawed premise and it continues to misunderstand disparate things and combines them in a way that doesn't actually yield what he is suggesting that it yields. So while he has missed the mark on some pretty important things, I applaud him for wondering what else could exist outside of these systems that we use, which work just fine for describing what we need them to describe. But they don't represent everything. I think to wonder and to muse about how else you can see things in this watered down model of reality that we interface with is a perfectly healthy exercise, and I think more people ought to do it more often. Could he use some guidance in the things that he is misunderstanding? Sure, and he should probably be encouraged to not build very high on a shaky foundation, but he's unfortunately encountering a great amount of flack from people who never wonder about anything. And I feel like on top of the correction that he is receiving in some of those important matters, he's also being discouraged from wondering by an extraordinarily cynical segment of the population who hears his stuff, and I don't like that. So I'm just here to encourage you, think a little bit bigger, wonder about what's outside of the systems that you use, or what other perspectives on those systems or the things that they describe could be. Wonder about those things. It's awesome. It's entertaining. It's enlightening. And he's probably better off for his exercises in that, even if he has strayed off the mark in some areas. I think the conversations that can be had around the stuff that he's brought up are very interesting. And so even his stumbling has not been a waste of our time, really. You all need to be a little less mean, and you need to learn to have conversations.